Dear students, let us now visualize the process of electroplating. For this, we'll require a circuit. Let us see the components of the circuit. You can see a 9-volt battery is there. Positive terminal and negative terminal is there. With the positive and negative terminal, two electric wires are connected. The red wire is connected to the positive terminal and the black wire is connected to the negative terminal. Okay. Now see, the positive terminal wire is having a free end. Okay. Whereas the negative terminal wire is connected to a switch, a simple switch, which I made by using safety pin and a piece of eraser and a nail. Okay, you can see at the base portion another black wire is connected, which is having a free end. Okay, so this will be the on position of the switch, whereas this will be the off position of the switch. Okay, now in this place we'll place a glass container containing copper sulfate solution, CuSO4. It is the chemical formula of copper sulfate. Okay, so I hope this electric circuit is understood by you all. We'll be using copper sulfate solution as an electrolyte for electroplating of copper. We already visualized that copper sulfate solution is a good conductor of electricity. We'll be requiring a glass container. We can use a glass beaker also for this activity. Let me first open this glass container. Now I will pour the copper sulfate solution in the glass container very carefully. We'll take as much as copper sulfate solution needed. Okay. This much would do for our activity. We'll now close the copper sulfate solution bottle as well as the glass container. Now we'll be requiring a small piece of copper plate and a iron or a steel piece which we will be electroplating. I don't have a thin strip of copper, that's why I made a stick-like structure from copper wire. This will also serve the purpose. Okay. Now we'll take the glass container containing copper sulfate solution. You will see that on the top region of the cap, two holes are being made so that we can insert the copper wire as well as the steel plate. Okay, You can see at one side capital A and on another side capital C is written. Here capital A stands for anode and capital C stands for cathode. Okay, these two things will act as electrode. Okay, we'll insert the copper electrode in the A hole and the steel electrode in the C hole. Okay, at this, okay, now let us insert the copper wire into the A hole. Pay attention that no deposition of anything can be observed in the steel electrode. Let us insert the steel electrode into the C hole. Okay, remember to place the two electrodes separate from each other. They shouldn't touch each other. Okay, now we will take the circuit and place the glass container containing copper sulfate solution in this particular place. Now we will connect the positive terminal wire with the copper electrode. Okay, we will just wrap this electric wire like this. Now we will take the negative terminal wire and connect it with the steel electrode. Okay, you can see the positive terminal wire is connected to the copper electrode and the negative terminal wire is connected to the steel electrode. This copper electrode will act as anode and this steel electrode will act as cathode. Okay, now let us visualize the process of electroplating of copper. As you can see, the switch is in off position. Now let us turn the switch in on position and observe the changes. The switch is in on position now. When electricity is passed through the copper sulfate solution, copper ions move towards the cathode and get reduced to copper metal. This copper metal gets electroplated on the object. Here the object is steel piece. The sulfate ions move towards anode. Okay, here the sulfate ions do not get oxidized. Instead, the copper metal of the anode gets oxidized to copper ions. These copper ions go into the copper sulfate solution. As a result of this reaction, at the anode, concentration of copper ions in the solution is maintained. Let us now leave the setup for 10 to 15 minutes and observe the changes. After 10 to 15 minutes, let us now switch off the circuit and disconnect the wires connected to the two electrodes. Now let us open the glass container and observe the changes occurred at both the electrodes. We can see that some copper has been scraped off from the copper piece and some copper metal is deposited over the steel electrode. Okay, the transfer of copper metal took place from the copper electrode to the steel electrode, okay, through the copper sulfate solution which acted as an electrolyte. Okay, now if I scrape off this coating, you can see the copper deposition very clear. Okay, it is a temporary deposition, not a permanent one. Permanent deposition can also be done, but some different procedure is there. As you are in lower standard, that's why a simple activity demonstrating the temporary deposition of copper through electroplating is present in your book. Okay.